Hello everyone. So those who are doing bibliometric analysis using bibliometric package and those who are scared of coding, for you we have a good news. The bibliometrics developers, they have come up with a new package, new tool called Biblioshiny, where you don't have to do any coding, only very basic, only a couple of basic codes which you can just copy from here. Okay, so let me show you how it works. Okay, so first I'm on my R window. If you don't know how R works or how to install R, please see our video on that. Okay, we already have a video on how to install packages and how to install R properly. So have a look on that. To start working with Bibliometrics, you first have to install the Bibliometrics package in R, and which I have already done. So I will just load the package, which is a library command. Okay, so if you have not installed the package yet, so you just remove this hash, okay, and then run the install package command. But I have downloaded it yet, I have installed it, so I'll just load the package, and then we give this command Biblioshiny and then brackets, and then it will load the Biblioshiny package, the Biblioshiny tool. Okay, or maybe it's good to say Biblioshiny app. So I click command, I run this code, and the Biblioshiny comes on my web explorer. Okay, so it looks like this. Okay, so here you have some basic information about the Biblioshiny thing, about the Biblioshiny tool, and I recommend everyone to read this article when you work with Bibliometrics package. Here you will find all the detail of each of the tools that are used in this app. Okay, so please go through this article, have a look on it. Okay, anyway, so when we have this, we can simply load our data file. And if you do not know how to load data file, please see our videos on that. We already have videos on how to load data from ISI Web of Science and also from use Scopus. So yeah, we cover both two largest data. So we already covered the two largest databases. So have a look on our videos how to extract data from these databases. So for now, I'm going to use the ISI Web of Science data, which is called Web of Knowledge as well. And here you see you have the option of Scopus, so you can use this type of data. And for Web of Knowledge, you have to use plain text. And when you use Scopus, that's when you have to use the bib text. Okay. So I'm just going to browse a text file that I have extracted from Web of Knowledge, which is stored in my laptop. So I'll just load it here. So I have like 207 articles here. Okay, so the loading is complete now. I can see the data here briefly. Okay, so I have about 207 articles. If you want to save in different formats, you can. Here we only have the Excel supported. Okay, but I'm not going to save anything. I will just proceed with the analysis with this Biblioshiny tool. Okay, you have this filter option here, so you can filter data based on publication years, based on citations, based on source and all these things. But I'm going to use all of it. Okay, so for the data side, first we have some aggregate information. We have like 207 articles published in 104 journals. Okay, then we have like 460 keyword plus, then authors keyword are 644. Our data ranges from 1982 to 2019. Average citations per document, total number of authors are 1513. So these 207 articles are written by 1513 authors. And then we have author appearances, single author documents, multi-author documents. Yeah, so we have all these informations here. And if you want to learn more about this information, please read this article. So there in this article, the developers explained it very clearly and very nicely how everything works. Okay, and we can also see annual scientific production. So for this topic that I have chosen and the data I'm using here, you see the publications in the recent years are the peak. In 2018, it's at the peak, and number of publication actually kind of increased exponentially. Okay. From source, you can see most relevant sources, which are the journals. So this is based on number of documents, as you can see it here. You can also, instead of if you want to save the plot, you can just right click and copy image, okay, or save images. You can use these two options. You can also see it in table form, okay. So we see the most number of articles for this topic was published in Transportation Research Party journal, okay. And yeah, we see the other journals. We can copy it from here. You can copy it in CSV, in Excel, in PDF, or print it, okay. So this is the relevant sources based on number of articles, but we can also see sources based on their citations and impact, which here we are calling H-index, okay. H-index normally means that, for instance, this journal here, Transport, their H-index is more or less 25, something like that, 24. This means that they have about 24 articles which were cited 24 times, okay. We can see it in the table as well, detail about the journals and all these things. Yeah. So their H-index is here, as you can see. Okay. So then we have this Bradford's law. But also, if you just do a quick Google search, you will find this, that it's actually about the exponentially diminishing pattern of searching for references in science journal. From here, maybe it means that these are the journals where the citations are increasing exponentially, and here it decreases exponentially for the journals in the later groups. I hope that's what it means, but I'm not sure, so have a look at it. Also, we have this source dynamics where we can see the journals, the number of articles published in journals. So you see, like, this journal is doing great here. The number of publications on this topic is growing exponentially in these journals. In other journals, it seems to be decreasing a little bit. Yeah. Here, yeah, it seems to be decreasing in other journals, but in these journals, it's increasing. So these things are interesting to see, actually, what's happening in the field. Okay. Then we have authors. So we can see most relevant authors, top authors based on number of documents. We can again switch between plot and table, okay. We can see authors' production over time. So yeah, like here we have the year, so we can see the production of authors, when they published and how many they published, okay. Over time, here we have the number of articles and total citations per year. We can see Lotka's law. Again, I don't really know much about this Lotka's law, but it shows kind of distribution of scientific production. So here, for instance, when we look here, it means that majority of the scientific production in this topic comes from authors with less than 2.5 articles, or like less than two articles. So most of the people in this field, they have written 1 or 2 articles, okay? And there are very few who wrote more than 5 articles in this topic, okay? And then again, you can see author's H-index. Again, you can go for table. You can see the most relevant affiliation. We see the TU Delft, TU Delft University from Netherlands. That's the top one in this topic, with a lot of articles, okay. And then Virtual University Brussels, that's also doing good, with Hunan University from China, okay. Then we can go to corresponding authors country, okay. So here we can also see, we see that the most articles are coming from USA, and SCP means single author participating country, and MCP means multiple author articles, okay. So here we see from USA, many people are writing single author articles, but yeah, for instance, for UK, many are collaborating. Again, you can see this information in tables, okay. But yeah, I'm just going through countries. We can see country-specific production like this. So we see production, most of the productions are coming from USA, and maybe some from China. So the darker, the more article. And you can see the same information in table. Yeah, you see USA, UK. We have most cited countries. So while USA was the top one in number of publications, but number of citations, actually Netherlands is the top one. Okay, and then we have this United Kingdom. Then we can move to documents, global cited documents, which means that total citation of a published article. So these ones, this article is having the highest one, second highest one. Then we have local citations, which means that the articles which received the most number of citation among these 2007 articles. And then we have most local cited references. These are the documents and these are the references. Which articles were cited most among the references of the 207 articles. Okay. References stethoscopography. Here we can see. So this is the number of cited references. Yeah, this is the cited reference. I also actually don't know very detail about this, but it's like references, and here you see the deviations within the past 5 years. So here it seems to be having some deviations. Okay, and we have most frequent words. So we see logistics, model, network, freight, management, optimization. Most frequent word. We can make a word cloud. Okay, yeah, here we see logistics and other words are surrounding it. We can change the number of words in our word cloud. We can look into different things like frequency, square root. I think frequency is fine. Shapes, we can change the shapes. We can change the type and other things. You can play with it. So if you want to do something, if you want to present something in your paper, so you play a bit and see which one fits the best with your topic and your title. Here also you can choose between different fields and other things. Okay, when I choose title, so this intermodal is a bit more dominant here. We can make a tree map. Here we see that this word is the most used and algorithm is the least used, maybe in this case. So these things are also nice. You can see word dynamics, the growth of words. Okay, so here in general we see emission is growing, transportation is growing, cost and network is growing, logistics is declining. Okay, policy is declining. Yeah, management is a bit declining. So that's all from there. Then we can move to conceptual structure. We can see co-occurrence network, which is, so here we see that there are about it's based on keyword plus, and you can choose between author's keyword, title and abstract, and you can play with different styles and layout, but if you choose the auto, then it will give you the best fitted one. You can go for normalization, non-normalization. These things are very nicely explained in the paper published by the developers of this tool. So have a look there. Okay, you can also play a bit here with number of labels and label size and all these things. Okay, so normally I see that there are about two clusters, two conceptual structures here, but it can change when we increase the number of articles, or here actually, yeah, if we increase the number of nodes, let's say to 100, it will, if we click apply, it may change. Yeah, as you see here, now we have some more clusters, more articles. So when we have more number of articles, it may change. Okay, so yeah, you have to play with it a bit to get the best one suited for your article. Okay, we can go for factorial analysis. Here again you can find the conceptual structure in your field. Here I see two clusters. Here again we are considering only 10 articles. I can maybe increase it to like 40 or something like that. Okay, and apply and see what happens. If I still have, I can maybe reduce the number of terms and see what happens. Yeah, it doesn't really look nice. So you have to play a bit to get a very good one. You can change the type of your method for looking into this conceptual structure, and the figure may change. So we have three options here: multidimensional scaling, multiple correspondence, and correspondence analysis. You can change between author's keyword, titles, and abstract. Here this map, like this each of these dots, they represent one article, and you can see it here. Okay, so this is the cluster. You see the articles here, which articles, and from this information you can find the article and discuss about them in your paper. And this red one is another cluster, and article surrounding it is representing this cluster. Okay, and the same thing, you can it can be based on most cited papers and most contributing papers. So again, you will get the most relevant papers for that clusters here and for these clusters here. Okay, we can also have a thematic map here, which normally should give you the themes in your articles and in your research. So this is how it looks. If I go to the table, then I see that I have 4 themes, 1, 2, 3, and 4. So one theme is about location, another from operations, another from network, and another is about management. So this sometimes helps us to identify the themes in our research field. Okay, and you can also look into thematic evaluation. I think I have not managed it to do it properly yet. Let's see how it works. Yeah, it looks nice. The themes are kind of explained nicely, actually, how they're related with each other. So emission is related with logistics, transportation, transport, and again logistic. Here we have optimization, models with networks, energy with network, systems and emission, all this related with networks. Yeah, it looks nice. We can see detail here. Yeah, you can see information about these themes and how they're calculated, the algorithm for calculating the themes. It looks nice, actually, I think. Please have a look again. I'm referring to the article developed by the developers. Have a look there. And then we can look into the intellectual structure based on co-citation. Okay, so this is co-citation network. Here I see there are 3 clusters, and these articles, they are one topic, one theme. And these articles are another theme, and these are another theme. Here again, you can increase the number of articles, and maybe you will see more themes now, maybe less themes. Okay. We have now 4 themes. It's very nice, actually, as you can see here. Okay, and you can see here detail which articles are on which theme. Okay, and you can again play here with different things. All these options you can try to play. You can see the co-citation of authors instead of papers. So which authors are co-citing? Yeah. This also sometimes gives us some nice information about the intellectual structure of a research field. You can also do it for sources, the co-citation among the journals, which 2 journals are cited together by other journals. So here, I think these informations are very nice, actually. Yeah. And it can really help you to identify the core structure of a research field. Also, we have the histograph, where it maps the articles based on the year of publication, and also it shows with the arrow who's citing whom. Okay, so this article cited this one, this article is cited by these ones and these ones. Okay, you can again also play here. You can have 2 different algorithms here, and you can change the number of notes. You can increase or decrease, which means number of articles. Okay, and note size, you can also make it small or big. And then in the end, we have this social structure, where we have the collaboration network. So here, for instance, we can see which authors are writing papers together. So these guys are writing together, these guys are writing together. You can also see it for institutions, which institutions are collaborating together. So we see Erasmus University and this university, they are collaborating together. Then here Eindhoven and VU Vienna, they are collaborating together in this topic. Okay, so we can see the collaboration of institutions. We can also see it for countries. Okay, so here you see United Kingdom is collaborating with these countries, and then Netherlands with Serbia, with Greece. I think this is a fantastic tool actually to map the research field. And then the last thing, we have world map collaboration. So this collaboration thing, we can show it in the world map. We can increase the number. So here, maybe if we increase it, then we'll see more connections. Okay, so at least if there is at least one collaboration between countries, it will show up now. But if we increase it now, there should be at least two collaboration between countries, and then it will show up in the map. Okay, and you can increase the age size. Yeah, you can increase, decrease, play with it, and show how it looks. And to see the collaboration information, you can click on the table. So like for now, when we have age minimum age 2, then this will not show up, okay, because this has only 1. So only the 2 and more than 2 will show up in the map. Okay, that's all. So again, thank you for watching this video. If you find it useful, please subscribe to our channel to support us, and like, comment, and share. And I think this is a fantastic tool for those who don't like to code, okay? Normally with R and Bibliometrics, we have to code, but Biblioshiny is great for those who don't love to code or who find it difficult to code, okay? And you can find, please, I'm telling it again, please read this article so that you get to know the detail about all these functions. Thank you for watching this video, and thank you for today. Please like, share, comment, and subscribe.